Welcome back to Research Methods. For today's lecture, we're going to be diving into measurements and testing, the kinds of tools you'll be using to accomplish the measurements for your research design. Now that you have your research questions set up, we need to start collecting data. And collecting data isn't just a one and done kind of thing. You need to make sure you choose the right tool for your research question. And that's what we'll be diving into, a little bit of the theory of how we take in that data, and then some of the practicality, what you need to know while you do so. So to get us started on this, we're going to start with the theory side of measurement and testing. How do we go from a concept all the way down to a tool that measures a reality or measures a phenomenon that we can then use in research? So that starts with concepts and operationalizing, and we'll move through different indicators, different steps towards abstract idea all the way down to this is statistical data I can then use. So every measurement, every tool, every survey starts with a concept. You have to make sure everyone agrees upon the definition of a concept, right? A concept is making sure that we're not just all bringing our own definitions to the table, because then you can't statistically analyze anything, because that's just everyone talking about their own opinions of a topic. So you have to start with meeting in the middle with not just yourself or your research group, but meeting in the middle of the entire body of research, all of the researchers measuring this thing. So for example, anxiety, I can't just agree upon a definition that works for me and my secondary. It has to be a definition that has been used before and will be continued to be used after my research design. The biggest reason for that is simply pedigree of thought. What that means is anxiety has been talked about in a certain way for so long. If I jump in with my own interpretation of anxiety, I'm not really having a conversation with everyone who's talked about it in the past. I'm kind of starting a new conversation. And there's places and times for that, but for the most part, when it comes to scientific observation, you want to make sure that you're observing the same thing that has been observed in the past, so that you continue adding on to the body of knowledge instead of creating a new path or a new thought or a new system or a new school. So that's why a concept starts with an agreed upon definition for complex phenomenon or abstract phenomenon. And that brings us to our next term, which is conceptualization, which is exactly what it sounds like, the process by which we make a concept, or the process by which we define a concept. And the biggest thing to know about that is simply setting boundaries to what a concept is and is not. It sounds kind of silly to talk about what a concept is not, but it's actually very helpful. Early psychology suffered from the lack of defining what things weren't, and that kind of opened the door to a lot of problematic definitions, mostly just not being quite falsifiable in their approach. And then lastly, this is the most important step, and the one you'll probably talk about the most in this class and classes to come, is operationalization. It's a big word, but essentially it means how do we take this concept and turn it into a measurement tool? How do we measure that concept, right? Now that we all agree about what anxiety is and what anxiety is not, that's great and all, but how do I measure anxiety? Know when it's going up and know when it's going down. What tools do I have to measure it? And that is where a lot of researchers tend to get hung up on, and you should get hung up on it because it is so important. Most research that comes out that researchers come back and say, no, that's completely wrong. They tend to disagree on the operationalizing of different terms. You didn't measure it right, you didn't set up your tools right, you didn't set up your measurements by operationalizing them wrong in the first place. So make sure, we'll get more into that throughout this lecture. Don't worry about it right now. So now that we have our definitions of the concept agreed upon, now that we've taken some time to operationalize what those definitions can look like as they're being measured, we have a lot of different tools that break down that operationalizing, that break down those steps of turning a definition of a concept into a statistical observable indicator. And a couple of those steps look like observables, right? So we have direct and indirect observables. Direct observables are measurements that have a very clear, obvious connection to the concept, to the definition. And the example I have here is using mercury metal in a thermometer. Why is that such a clear connection? Well, metal expands and shrinks based on the temperature around it. So using metal that's very sensitive to that temperature around it in a glass tube to then measure temperature is a very clear and obvious connection. As the temperature changes, the metal moves up and down the glass tube, pretty one-for-one directly. So that is why it's a direct observable, a direct connection between concept, which is temperature, and the observable, the measurement, which is the metal in the glass tube. Now, some things are not so simple and straightforward as temperature. Some things are a lot more complicated, like happiness. So when you get to topics like that, your measurements sometimes need to be more indirect, more flexible. They need to come at it from an angle. So indirect observables are measurements that require some form of interpretation, some form of discussion to really make sure that the concept is measured by this indicator. The example I have here is number of smiles per hour to measure happiness. Right? Now that's indirect because sometimes smiles are not about happiness. Sometimes smiles are more about politeness or manners or something entirely opposite to happiness, right? But some smiles are related to happiness. So it takes a bit of interpretation, a bit of discussion. Maybe it takes more than one indirect observable to really measure happiness. But that's why it's considered indirect, because you need some form of angled or around the side approach to really get at something as complicated and layered as happiness. So again, we have direct observables and indirect observables. So indirect and direct observables are both something called indicators. Indicators are those tangible markers that represent the presence of that abstract concept, right? So an indirect indicator would be shouting as an indirect indicator of anger, right? And then a direct indicator would be cortisol hormones in the blood as a direct indicator of stress. Why is that direct? Because cortisol is literally a stress hormone, or a collection of stress hormones. So each one of those is an indicator, and that's a word to really make sure you have down, as we're going to use it a lot moving forward in this lecture and in this class. Now, sometimes some concepts are so complicated and big and multifaceted that you don't need to just break them down with indicators. You actually need to break them down first by larger categories called dimensions. Right? So a dimension is subcategories of a big, broad concept that's multifaceted, has lots of angles or layers to it, that's really complex. And those dimensions help bring clarity to the measurement, because you can't just measure the whole thing all at once. You need to make sure you take steps in measuring different pieces or aspects or dimensions of that larger thing. So let's walk through an example together to really understand this. The example I have here is population health, right? If you're in charge of a city's health, right, you might have this big concept, population health. Now that's really big, and it needs a lot of breakdowns, but even those breakdowns could use breakdowns. So we start with dimensions, right? And three example dimensions I have here are diet, exercise, and mental health, right? Is it comprehensive? No, but it's a good start. And each one of those dimensions, diet, exercise, and mental health, can then have their own indicators, right? So an indicator for diet might look like, does the city generally have access to affordable fruits and vegetables, right? Some indicators for exercise might be amount of walkable sidewalks in the city. And then another indicator for mental health would be the number of free community events that either are the arts or just some form of food gathering, celebrating holidays together, things like that. Now, some of these are going to be direct and some of these are going to be indirect, depending on the measurement that you're going for and the complexity of that larger study, that larger concept. So the largest concept here is population health. The dimensions are exercise, diet, and mental health. And then each one of these has their own indicators and observables. So it's really important to start with the theory of measurement. You have to make sure you have solid definitions and concepts before you operationalize and measure. Because if you get a ruler out to measure happiness, you'll end up wasting a lot of your own time. So operationalizing and conceptualizing, making sure you have your direct and indirect observables down and agreed upon, those really trim up a lot of the work that you'll have to do in post, but it also makes sure that you're actually observing what you want to observe, and that's something called validity, which we'll get to in a little bit. But what happens after you have well established that step? After you have well established the operationalizing of your concept, you have to make sure that you then continue to use the right tool, the right statistical tools for your research project, right? So we're going to talk a little bit about the levels of measurement, what that means statistically. We're going to talk about validity and reliability. Are you measuring what you want to measure? But then we're also going to talk about some pretty common methods of measurement. So the first tool of measurement that we'll be looking at is levels of measurement. Now, what this means is what kind of statistical data are you pulling in, right? Are you using nominal data, ordinal data, interval data, ratio data? Now, at first, when you see these four terms, you might go, what on earth are we looking at? But really, it's just a way of statistically organizing what kind of information you're pulling in, right? So we're going to go through each one of these one at a time, and we're going to look at their strengths and their weaknesses, and then hopefully by the end of that, it won't seem so daunting. It's a big old grid here, but it's not that big of a deal. So let's start with nominal data. Nominal data is purely categorical. It literally means name. Nominal is name. And in some ways, you can think of it as name-only data. Name-only data kind of looks like stuff like race, marital status, what kind of pet name they prefer. It's data that you can take in, but you can't really compare it to any other category, or you can't compare it to itself. There's no order up or down. It's just a yes, no, I prefer this, I prefer that. Someone's race is not really comparable to another person's race as either higher or lower. Someone's marital status doesn't really give them a closer to the end of the scale kind of idea. It's just a marital status. And of course, pet name preference is simply that. It's just a pet name preference. It's a name only kind of data, nominal. So we call this categorical data, and categorical data gives you correlations, but it can't really give you causation. No amount of nominal data will ever give you causation kind of hypothesis support. So you can see here on the left side, order, equal, and meaningful zero. What do those mean? Order means does this kind of data have an order to it? And obviously with nominal data, no. Race is just race. Marital status is yes, no, something in between. And pet name preference is just that. It doesn't actually set up first, second, third place. It doesn't set up higher or lower standards. There's no order. Does each step have equal distance? Of course not, because there is no distance and there's no meaningful zero in any of these. Someone could argue that marital status could have a meaningful zero, but not as far as stats is concerned because it's still nominal data. Now we're going to move over to ordinal. So ordinal is rankings. It's first, second, third, fourth place. So it does have an order, but it doesn't tell you what the distance is between first and second place and second and third place and fourth and fifth place, right? So if a whole bunch of sprinters for the 100-meter dash go at the same time and you look at rankings, you'll know who came first and second, but you need more information if you're going to find out by how much they won, right? This is very important for schools offering scholarships and things like that. So knowing who came in first and second, that's ordinal data. It has an order, but the distance between first and second and third might be very different. So they're not equal. They're not equal, and you can see that on the grid here. And there's no meaningful zero because with ordinal data, if you get a zero, that means that you're just missing data. So this is very helpful for rankings. It's helpful when you're trying to mostly get something quick and ordered, but it's not very helpful if you're trying to do like deep causational kind of hypotheses. So this still falls into categorical data because we don't know the distance between first and second place and third and fourth place, because those could be very different. That kind of sets up your stats to be limited as well. Likert scales fall into this. So when you think of a survey rate, were you somewhat dissatisfied, somewhat satisfied, that 1 to 5 scale is considered ordinal, because we don't really know how close people are to neutral versus dissatisfied. There's a whole bunch of range of interpretation there. Let's move up one more to interval. Interval this is the step we take from categorical data to numeric, right? The distance between 1 and 2 and 2 and 3 is the same. So there is an order and there's equal distance. There's equal intervals between each step, right? So elapsed time. Time 1 second to 1 second to 2 seconds is the same as 2 seconds to 3 seconds. That is the same amount of distance in that time. And Fahrenheit also has this order of hotter to colder, and it has equal steps between each degree, so that makes it interval. It's not ratio yet, and you'll find out in a moment why. And the last one, the one that everyone likes, is ratio. This is numeric. This is statistical significance with interval and ratio. Because there's equal distances in the interval, you can technically start working towards causational hypothesis support. But ratio is everyone's favorite because with that meaningful zero, that statistical strength, most statistical equations really like having that dead zero, because then it can flesh out other mathematical things you don't need to know about right now. But what this looks like is income, right? Someone can have absolutely no income, right? And other things like that can have absolutely zero kinds of statuses. That makes it ratio data. So again, we have the 4, nominal, ordinal. Those are both categorical. They're not quite as strong in statistics as interval and ratio, but they can still be useful in their own ways. So the next question after that long spiel on that big old grid is, why do these different levels matter, really? Why does it matter what kind of data I'm pulling in, and why does it matter that I need to know? Well, actually, the previous instructor, Dr. Miller, she had a really good slide on this, so this is her information here. I just liked how she worded it so well. So the choice of level dictates the type of statistical analysis that you can do later, right? You can't run half of your statistical analyses on nominal data. You can't. The data will not work that way. You can't force name data, nominal data, to be number data and create anything more than correlations and try to make a hypothesis, a causal hypothesis out of that. And also, what kind of data you use influences the interpretation of the results at the end of everything, right? If I use only ordinal data, I can know within a certain range how strong my significant finding is or the effect size is. But if I use a ratio, that range of how well I know what I know gets very specific, and I can say something with a lot more confidence, right? So if this is a range of, yeah, I mean, it might be up here, it might be down here. Well, an ordinal scale has a larger range of what it might actually be, and a ratio scale is a lot more specific and confident in what kind of conclusions you can say. And then determines the granularity and depth of insights that can be extracted from data. The closer you get to ratio, the more precise a lot of effect sizes can be. And this can work for or against you depending on how you do your statistical analysis, but this is why levels matter, right? So you want to shoot for the highest level you can with your concept or your abstract operationalized method, because then you can make stronger claims and more causal claims. That's not always possible, but doing what you can to push that statistical intake further and further down the levels is very helpful later on in your statistical analyses. The next tool we'll be looking at is validity. Now, validity is the strength of the connection between the operational and the concept itself. How strong is the connection between my measurement and the thing I actually want to measure? Are they actually connected very strongly? Now, this is very important because you don't want to waste time opening up a ruler or pulling out a tape measure to try and measure happiness, because then you're just wasting time and resources, not actually studying the phenomenon you want to observe. So validity is a good way to stay on topic with your concept and with your operationalizing. Make sure that your measurements are all cohesive on the research question. At first, validity sounds very simple, but the deeper you dive in, the quicker you find out that there's lots of facets and layers to validity. And we're going to dive into just a short list of those. And I know it looks like a longer list, but it is actually only a short list of different kinds of validity. So let's get started with face validity. Face validity is, does the measurement seem to measure what it should be measuring? Does it on the face sound like what it is? It is the face validity. This is less for the researcher and more for the participant. A participant doesn't want to come into a depression survey and then get handed a questionnaire about automobiles or a title about automobiles. It might confuse them on what's really happening, and a confused participant is a wrench in the whole research process. So make sure that your measurements sound like they measure what they're supposed to for the sake of your participant. The next one down is called content validity. This is the question that I have for this one is, does the measurement contain all of the necessary facets of the given concept? If I'm doing something big like public health, I don't want to leave out any major dimensions. I don't want to do diet and mental health and leave out exercise, right? If I want to capture and contain the entire concept of population health, I need to make sure that my measurements actually have all the necessary dimensions, facets, indicators of that concept, of that construct. The next one down is criterion. Does this measure predict outcomes from a given score? If I get a score on someone's depression survey, does that score actually tell me, yes, they are depressed, or predict that they could be depressed, or support a hypothesis? This one's more about numbers. The next validity down is convergent validity, and this one asks the question, does my measurement fit into the fold of everyone else's measurement when we're talking about the same concept? And what I mean by that is, if I have a depression survey, is it similar to other depression surveys in measuring depression, right? If we're all in fact measuring depression together, then my measurement should behave similarly in the scores, in the stats, to other depression surveys. If my depression survey has completely different outcomes than every other depression survey, I might be measuring something wrong. I might have something defined incorrectly, or something else might be going on that has kind of thrown a wrench in the whole process. And then lastly, discriminant validity. So convergent is how well my measurement works with other kinds of measurements on my same topic. And discriminant validity is much more about, am I not researching what I should not be researching? Does my measurement not measure what it should not measure? So it sounds kind of silly at first, but setting that limit and making sure that your depression survey doesn't really line up with anxiety surveys is very helpful to know that you're on the right path. I like to have a pad of all of these questions nearby when I set up my research design. I have found that it really clarifies not only for me what I'm working on, but anyone I'm working with. We can all agree, oh, okay, these are the questions to have in mind as we progress through these measurements to make sure that we're staying on topic. So now that we've looked at validity, something that goes hand in hand with validity is reliability. Validity asks the question, am I measuring what I want to measure? Reliability is, how am I doing that? Am I doing that well? So reliability is a way of knowing how consistent the measure is from context to context, person to person, time to time. It's really important that the test is consistent from researcher to researcher, population to population. If my depression survey only ever works for me, it's not a good survey. If my anxiety survey only works in one city or one state of America, it's not reliable. It's not reliable, which means it has limits on what it is actually measuring, and it has limits on what the statistical significance can, like the different conclusions you can draw from this test. So there's three major aspects about reliability. Test and retest reliability is the first one, and this is how stable your test is from moment to moment over time, right? If someone takes your test and then 20 minutes later retakes that same test and gets completely different scores, something might be amiss. Now, for some tests, this is more expected, right? There is a practice effect that we need to consider. But how much is a practice effect versus how much is a reliability problem? There's actually some statistical analysis formulas that can help with that question. And then the next element of reliability is internal consistency. How stable is the test within itself, item to item, right? I'm not going to ask one question, how anxious are you? I'm going to ask that kind of question 5 or 6 times because I want to not only get that one question well represented, but I'm also trying to make sure that the participant gets to answer the question in a full-rounded, well-rounded way. Well, now the next question is, does each of those anxiety questions actually interact with each other well? Does my question 1 about anxiety match up with my question 3 about anxiety consistently, right? Is the test consistent within itself? Or is there one question that's way out there, way off on its own? Everyone answers this one to the highest degree possible, and no one answers any of the other questions that way. What's up with that one question? What's up with that one item? So internal consistency is about how stable the test is within itself, right? And then the last reliability we're going to talk about is inter-rater, right? If this examines how different participants give consistent reports of the same phenomenon. So one way I might get good inter-rater reliability is make sure I'm going to hand my depression survey out to 100 people who've already been diagnosed with depression, which means I kind of would like to see a similar score across that board. Right? If some people answered wildly different than others, but they all technically should have a similar score, that tells me that something's not reliable about my tool of measurement. Something's wrong here. Now, reliability is also wildly dependent on implementation and protocol, right? Is the researcher conducting this survey in a consistent way that allows the survey to speak for itself and there's no researcher bias going on? We're going to talk about that a bit more in a couple of slides. So as far as tool of measurements go, we've talked about validity and reliability. Those two go together really strongly. It's very important to get those right. We've talked about levels of measurement. That's the statistical approach. Now here are some general tools that get used pretty frequently when it comes to taking in measurements, taking in data. We have self-report, behavioral measurements, and physiological measurements. These are the main three categories. I'm going to start actually at the bottom of the list and go up. So when it comes to physiological tools, this is when you walk into a doctor's office, what doctors tend to use, right? How do we measure blood pressure, and how do we measure like cholesterol in the blood? These are tools that tell us about the body, what the body is going through, and those kinds of tools tend to be very direct observables, direct indicators, and they're very, very common. We also use things like MRI and CAT scans and PET scans, especially for measuring brain activity. But another major category for tool measurements is behavioral. And this is simply watching someone either in a lab environment or a natural environment and just clicking how many times you see them performing an action or behavior in a certain way or at a certain time, just mostly counting how many of those behaviors occur, don't occur, or the degree to which those behaviors occur. Does someone help someone else when they're crying, right? How often does that happen? A follow-up question might be why, but that wouldn't be a behavioral question. That would be a self-report question. If someone walks by another person on the sidewalk and one person is crying, does the walker help? That's a behavioral observation. But then the follow-up question of why did you help? That would be a self-report. And those measurements are where the participant answers their own series of questions about their thoughts, feelings, and behavior. Now, each one of these has its own strengths and its own weaknesses. I mean, physiologically, there's a lot of strength there. You can't really lie about how much cortisol is in your blood. So when you ask someone how stressed they are and you take a blood sample and measure cortisol, there's no lie in there. There's no interpretation there. You get a very direct answer. And it's a very direct observable. And same thing with behaviors, right? How often does X, Y, Z happen? Well, you can just go watch it happen. But they have their limitations because they don't actually answer what's going on within a person nearly as well as a self-report might. Now, self-report, though it opens the door to what's happening within a person, it also has its limitations because then you ask the question, you're kind of looking within a person through the lens of that person's self-image, which can have some cracks or maybe even be entirely wrong. We can list a large number of biases about the self that we know happen all the time, but it's hard to get that inner peak without also involving some form of self-report. So we've talked about some of the theory of measurement. We've talked about some of the common tools of measurements. Now let's talk about some of the challenges you'll be dealing with day in and day out when it comes to doing measurements. Each step of the research process has its own challenges, and measurement is no different. Measurements are no different. So let's start with the normal everyday research challenges that you're going to have pretty frequently. And this would be culture, biases, and subjectivity and variability, right? So let's start with the bottom and go up. Let's start with subjectivity and variability. Every one of us is a very complicated mesh of things going on emotionally and physiologically and socially, environmentally. And because of this large complication web that is a single person, whenever you conduct research, you also have to take into account that every person who participates in your research is also that variable. Some people may come into your study hungry. Some people may have come into your study having just had an argument with a best friend. Some people may have just lost a job when they come into your study, and that each one of these things is a variable that you cannot really account for. You can work as hard as you can to mitigate some of those things, but for the most part, people have lives to live, and because they have lives to live, there's something wild that is likely to happen in at least one person's life, which will change the answers they give. And we're going to move up to biases now. There are three major biases to know when it comes to research: observer bias, self-report bias, and test-taker bias. All of these inhibit measurement and implementation and must be considered when you're making your tools. What does this mean? Observer bias is people tend to change simply when they're being observed. I mean, I know I don't behave entirely casually the moment I see someone walk in and say, "Hey, can I observe you?" I mean, I'll say yes, but I will also act a little differently, depending on why they want to observe me too. Then we have the self-report bias. For a plethora of reasons, someone might report themselves either higher or lower on a confidence scale. Someone might think of themselves as too arrogant to say they're very confident, so they might report themselves very low, and so on and so forth. And then there's the test taker bias. This one is a lot more about how people want to, they know that the test is asking a question, so they might actually try to answer that question and give the answers they think they should give. Kind of like a student in high school might want to give the right answer on a test. They might try to give you the right answer on the survey, and that bias also inhibits just the natural response that we're trying to observe or the phenomenon you're trying to observe. Which then leads us into the last one, which is culture. Values and behaviors and even our perceptions are all very culturally influenced, and because of that cultural influence impacts just how generalizable a measure can be and how reliable a measure is too. If you try to give your confidence survey to one group of people who culturally they highly value confidence, you're going to get one set of answers, right? Obviously, very high answers. Now, if you go give that same confidence survey to a group of people who value it differently, you're probably going to get very, very low answers. But in reality, the confidence, the phenomenon you're trying to measure might actually make both groups more normal based on how you're operationalizing or trying to understand that phenomenon. But the words you used in your measurement in your survey, just the words themselves could they have to pass through that cultural filter, and because they pass through the cultural filter, they alter the kind of responses you'll get. So this is where we slow down and try to make sure we operationalize as well as possible to leverage and mitigate some of the challenge of cultural differences. But it's not entirely possible. It's not entirely possible. You're always going to be dealing with cultural values, cultural perceptions, as a lens through which people take your surveys and do your research. Another challenge, another question to ask when it comes to doing your research question is, do I use someone else's survey or do I make my own survey? Do I use someone else's measurement tool or do I make my own measurement tool? And there's pros and cons to both of these approaches, right? So let's start at the top. What are the pros and cons of using someone else's measurements tools? Well, the first pro is it's a lot faster. That tool already exists, right? And they've already gone through the work of proving the reliability and proving the validity. That's a lot of work, and they've already done it. And thirdly, it's a part of the pedigree of thought. right? You already know that someone else's measurement is connected to the larger research conversation around a phenomenon. So those are things you no longer have to worry about, and it makes using someone else's measurement very tempting. Some drawbacks, though, is sometimes your research question doesn't really fit perfectly with someone else's measurement tool, right? Um, and another thing to consider is as time progresses and measurements change and things like that, has that measurement tool been overturned or challenged in more recent research? Does a depression measurement from the 70s still hold up today the way it should? Or does it need, or has that been completely overturned and no longer usable in today's research? Um, but then the next question is, do I create my own? Do I create my own measurement tool? And to that, I say there's lots of pros, right? It will always fit your research question. It will perfectly fit your research question because it's you who makes it, right? It also opens up the door to really brand new or novel research options, which makes you much more publishable. It makes you much more publishable. And then because you're creating this measurement tool for your research question, there's a lot more adaptability to different cultures you're working with and different contextual needs that you have working with the populations you know you will be working with. What are the cons? It is so much work. It is. It is so much work to develop a tool. To make a reliable and valid tool takes a lot of not just work on your own part, but you have to work with other people to make sure that all the cultural contexts are considered. You have to work with other peers to make sure that your operationalizing is strong. Some people you have to go through several series of publishing the tool in the first place, which is publishing is its own process, and then going through the statistical analyses of reliability is also a lot of work. Making your own measurement tool is not something to be taken lightly. But if you are going to take that route, here are some things that you should be considering, right? Please start with a strong definition and a strong concept and a clear one, right? Make sure that anyone who's walking by your work, your definition, your concept, they can look over your shoulder, read it, and understand it pretty quickly. It has to be clear, not just strong, but clear. If it's not a clear start, every step you take after that will be very, very difficult, and you'll probably end up having to rework things anyway. So always start with a clear concept, a clear definition. Operationalize with high scrutiny. Basically, just have really high standards for what your measurement indicators are. Have really high standards for what direct and indirect observables are. Have really high standards for your levels of measurement. Have just higher standards, right? The higher standards you start with, the cleaner the outcome at the end. Make sure you check with peers for validity and ethical concerns. You can go nearly blind looking at the same measurement tool that you've been working on for a very long time and still miss things. Bringing it to peers really opens up the door to catching things that are hard for you to see now because you've been looking at the same question for so long. But bringing in your peers helps undo a lot of those validity and ethical oversights, because now it's not just your brain, your tired brain working on it, but someone else's too. Then after all that is set up, you got to start testing for reliability and validity ASAP, and for as long as you can before you need the tool. One thing to consider is you might be only given so much funding for a project. So if you spend a lot of that funding on creating your own tool, you might have less funding for using that tool to answer research questions. So there's a lot to consider when making your own research method and your own research tool. The last set of challenges we're going to talk about today are researcher implementation, right? We researchers are still people. We still have our own biases and our own expectations, and these affect how we conduct research. And because we conduct research a little differently, participants pick up on that, and we may end up getting skewed results based on our own expectations and biases. We have our own cultures and we have our own lens through which we see the world. And the more you acknowledge that and the more you practice knowing what your value systems are and your lenses are, the more clearly you can see. But at the end of the day, we are still humans trying to study humans, and we are limited because of that. So there's a couple of steps we can take to try and mitigate some of those biases and challenges. And one of those is standardized testing for everyone. Environment must be standardized, the instruction delivery must be standardized, every participant gets the same treatment and people respond to them the same way. Those are all things that can be standardized. Blind research designs whenever possible, right? We talked about in our research design a little while ago that blinds are when even the researcher doesn't know what treatment the participants are getting. Random assignment also helps making sure that the researcher doesn't have a say in who gets what and who does what. And those blind research designs and those random assignments help a lot with mitigating researcher bias. And then another thing to always ensure, not for only for ethical concerns, but for participant standard experiences, is always ensure the same anonymity and the same confidentiality for every participant. If every participant feels like they can be fully open and honest, then you're more likely to get an honest response from the participant. And if that anonymity is not equally distributed, or if the participant feels like it's not equally distributed, that's when researcher bias can really play a role in skewing results. Lastly is that implementation piece. If you are the head researcher, you are likely going to be implementing a lot of the research itself. You'll probably be conducting interviews, conducting surveys, giving surveys, but you probably won't be the only one. So making sure that you train other people, other researchers, assistants correctly and completely is kind of its own skill, but it's important. I have to make sure that every assistant who gives my survey does it the same way I would, right? And not only that, but any researcher who reads my stuff and then wants to conduct their own work, research using my measurement tools, I have to make sure that they have the instructions and the know-how to conduct the research consistently too. So that's like its own separate skill, being able to train others up and to train your writing in such a way that other people can pick up your measurement tool and use it. That's its own skill to develop, not just research design and statistical analysis. That's all I've got for you guys today. I hope you have a wonderful time, and I hope this helps you understand the complexities and the theory and the practicality of different measurement tools.